Hello everyone, welcome to our course in Algebra 2. In this course we're going to learn all about different families of functions, how to use them, graph them, solve them, and hopefully make sense of mathematics as a whole. So our first unit of study is just called the basics of algebra, and our first lesson is on evaluating algebraic expressions. Before we dive into this, let's take a look at how you can get a copy of these notes to fill out yourself. If you go to my webpage, or just Google my name, Jed Wilshire, or you can check for a link to this webpage in the description for this video. You can go to the Algebra 2 link, and you'll find Unit 1 lesson notes right here in the Algebra 2 folder. So there's my webpage, and then click on Algebra 2 and select Unit 1 lesson notes, as well as the Unit 1 homeworks. You'll want to get a copy of those to work, and the homework answer keys to check your work. From time to time, when we do need to use a graphing calculator, I'll be using the Desmos online calculator, and you can get to that at www.desmos.com. And it's a really handy tool. I think you'll really like it. Okay, let's go back to our notes. First, we're going to do an example together. So I'm just going to make a copy of this and paste it into a paintbrush window, a paint window. And I'll evaluate them here. All right, 2 minus 3 times 4. Well, I think we all need to just take a moment to review how to evaluate expressions, because some of you have used calculators almost exclusively. Others of you, this is super easy. We want to make sure that we take a second to review it. So you probably heard of PEMDAS, the order of operations, or from math. But please remember that these two are ties. So multiplication and division, addition and subtraction, it's based on left to right. All right, let's take a look at this first problem. 2 minus 3 times 4. The order of operations says I need to multiply first and get 2 minus 12. And now I'm subtracting 2 and 12, which is 10, but because the 12 is negative, it's a negative 10. Remember, you take the sign of the bigger number. All right, let's take a look at B. Now, you may think that this is 9, but the answer is not 9. Let's take a look at why. Exponents are only applied to what is immediately in front of it, not the negative sign. This is actually the same thing as -1 times 3 squared. So we need to keep that in mind, that a minus sign is really a -1 times something. So this is the problem. 3 squared is 9, and then we still had that negative out in front. That is so important. I would say that this is probably the cause of more wrong answers on any test I give in any class, is not understanding that the squared only goes to the number immediately in front of it. All right, letter C is definitely a different situation though. We have another even power, and whenever you're multiplying an even number of negatives together, you do get a positive value. And since the negative is in the parentheses with the 2, the 4 will be applied to both the negative and the 2. So multiplying 4 negatives together, that's an even number of negatives, so the answer will be positive. And 2 times 2 times 2 times 2 is 16. All right, next. Okay, this is a division bar, but it's also a grouping symbol. Says we have to do everything on top first and then everything on bottom. 5 minus 7 is a -2 because 7 is bigger than the 5. 2 plus 4 is 6. Now we're going to reduce this. What goes in the 2 that also goes in the 6? Well, 2 does. 2 divided by 2 is 1. 6 divided by 2 is 3, making our answer a -1/3. third. Okay, now I think you've got some practice problems to do. So the way this works, you pause the video, answer these questions to the best of your ability, and then we'll go over the answers. All right, welcome back. Let's see how you did. So on this one here, I have -3, and I have to use multiplication first. So it's -3 minus 8 is a -11. Because the signs are the same, it's like adding. 3 plus 8 is 11, and then you take the sign they have in common. Now I have 7 minus 5 squared. We do the exponent first, but it does not apply to the negative. So this is just simply 7 minus 25, which will be a negative number, and then 25 minus 7 is 18. You know, some people struggle with that kind of subtraction, so feel free to go over here on your scratch work and just, you know, do 25 minus 7. Just make sure you put the negative sign down where you're going to put your answer before you forget. But you do have to subtract them in the correct large number minus small number, or else you'll get the wrong answer. So, you know, you would borrow 50 minus 7 is 8, and then bring down the 1, making it 18. All right, over on this one, we have a negative, but it is squared, so it becomes 7 plus a positive 9, which is 16. All right, then on this one, I have 7 times 2 minus 4 is going to become negative because we're subtracting a bigger number from a smaller number, giving me a -14. 7 times a -2. All right, I hope you had good success with that. And let's see what's next for us. All right, we're going to evaluate some rational number expressions. So let's take a look at it. Okay, so we have 2/3 plus 5/6. When we add or subtract fractions, we need to get a common denominator first. So what I'm going to do is think if there's a number I can multiply the smaller denominator by to get the bigger one. Well, if I multiply 3 times 2, I would get 6. So I'm simply going to multiply by 2 on top and bottom of this fraction. You know, it's really important that we review how to add, subtract, multiply, etc. with fractions, because you'll be using fractions with algebraic expressions in them. So we want to make sure that we have our fundamentals down pat. 4/6 plus 5/6. Well, when we get the common denominator, all we do is add the numerators. So just add 4 and 5 together to get 9/6. Now we're going to try and reduce. We're going to be reducing in the same way that we made 2/3 in the 4/6. We're going to think of something and do it to the top and the bottom. A number I can divide into 9 and 6 is 3. 3 goes into 9 3 times, and 6 twice. So my answer becomes 3/2. I wanted to change color there. Oh, I clicked on it with the wrong mouse button. That's why. 3/2. There we go. All right, let's take a look at this next one. All right, well, there is a smart way and a not so smart way to do this. The smart way to do this is to realize that I can reduce any number on top with any number at bottom before I multiply. So I don't need to multiply 3 times 5 times 8 times 7. I don't even want to know what that number would be. But I can divide this 7 and this 7. As long as I've got nothing but multiplication in the problem, I can reduce anything on bottom with anything on top. Likewise, I'm going to call this 2 and 8. I'm going to reduce this to a 1 and a 4. And the 5 and the 5 will also become 1s. So I'm kind of crossing them out, but these little cross-out symbols are actually like 1s. So I just have 3 times 1 times 4 times 1. Well, that's just, oh, you know what? We're not done. I didn't even notice it, but the 3 and the 9. My goodness. 3 goes into 3 one time. 3 goes into 9 3 times. All right, so I now have 1 times 1 times 4 times 1, that's 4. And 1 times 1 times 3 times 1 is 3. Now, isn't that easier than trying to multiply all those numbers out? All right, let's take a look at the next one. 7/5 divided by 21/25. Well, we're going to do keep, change, flip. Keep, the first number the same. Change the divide to multiply. Flip the second fraction. All right, keep 7/5. Change to times. Flip the second number. All right, and we're going to do it smart. We're going to reduce first. 5 goes into 5 once, and 25 5 times. 7 goes into 7 once, and 21 3 times. Making our answer 5/3. All right, 3/5 divided by 2. Okay, well, there is a little trick to this one, but let's keep our keep, change, flip going. Keep the first number the same, change the divide to times, and flip 2. Well, that's 2 over 1 if you think about it that way. So it's 1 over 2. And that gives me 3 on top. 3 times 1 over 5 times 2 is 10. Remember, when you multiply fractions, you don't need a common denominator. You just multiply across the top, you multiply across the bottom, but always remember to reduce first. One thing I want to point out is that when you take a fraction and divide it by a whole number, like we did in example D, that number just multiplies to the bottom. That's the trick I was talking about. That's a 10, by the way, not a 16. All right, I think you've got some practice problems to do, so you know the drill. Pause the video, and then we'll come back and talk about them. Okay, it's time to see how you did. Get a common denominator on this first one. Unfortunately, I can't multiply 3 by anything, at least anything nice, to make it into a 5. So I'm going to multiply this 5 by 3 and this 3 by 5, and I'll do it on top and bottom. So I'll say 3 over 3 times 2/5. And for some of you, this level of showing your work might be a little bit unnecessary, and that's fine. You show just as much as you need to here. Well, that's a terrible looking 5. But I'm going to show it all because, you know, I'm supposed to be teaching it, right? So let's see here. 3 times 2 is 6 over 15. And that's 10 over 15. And so we've got our common denominator, so the answer will be over a 15. And we have 6 minus 10, so that's a -4 because we're subtracting a bigger number from a smaller one, so the answer is negative. -4/15, and that does not reduce. Okay, so here we go. Keep, change, flip. Hopefully that negative sign didn't mess you up too much. It just means we're going to have a negative or answer. If you want to put the negative somewhere in the fraction, you can put it to the top or the bottom. I usually put it to the top if I put it anywhere. But don't put it both, or else you'd be actually changing it to a positive. So if you prefer, we can put it up top like that, or just leave it at the side, but I'll write up at the top. Keep the first number the same, change the division, the multiplication, flip the second number. And I get -5 over 2 times 7 over 2. Nothing's going to reduce right now, so I just multiply across the top. 5 and 7 is 35. And 2 and 2 is 4. And if nothing reduced before, nothing's going to reduce afterwards, so with multiplication, that is. So we're done. All right. Ooh, these are some big numbers. Hopefully you whittled this down. 11 goes into itself once, and 121 11 times. That's 11 squared. 7 goes into itself 1 time, and 63 9 times. Making the answer 11 times 9. I love multiplying by 11. You just write the number down twice. Over 1 times 1, and you know that means divided by 1. Well, anything divided by itself is just itself. But please do not, under any circumstances, turn in work in a high school math class with a number divided by 1. If you like to put that over 1 and look at it and feel special, fine. Take it one step further and rewrite it without it, or erase it. And I'll tell you why. Because knowing that a number divided by 1 is itself is important. And if you write over 1 and don't reduce that, I don't know that you know that. So it's very important that you don't leave it like that. All right. 8 divided by 2/3. Keep the first the same, change the second, and I'll go ahead and put the over 1 here. See, it's okay to put over 1 to help you do your work. Just don't leave the answer that way. I'll reduce the 8 by 2, and I get 4 times 3 is 12, and over 1. Just take a second here, make sure that that feels good to you. 8 divided by 2/3 is 12. Well, I'm dividing by a number less than 1. So if I take some whole quantity and divide it into quantities that are smaller than 1 unit, I should get a bigger number, right? So hopefully that does make sense to you. All right, what's next on the docket? It looks like you have another set of practice problems. So I'm going to have you just go ahead and try that yourself right quick. Pause the video, and then we'll meet back here in just a second. All right, evaluate if possible the following expressions. If the expression has no real value, simply state no real value. Exactly 2 of the following have no real value. All right, that's my hint. First of all, I want to talk about this word real. You might be a little bit confused about that word and why I even put the word real in it. We're going to talk about that more later, but for now, I want you to think that real means it could be whole numbers or decimals, any of those values. So if I say integer value, then I mean only whole numbers, or rational values, that means only fractions. But if I say real, I mean any of those numbers. Negatives, they don't have to be positive, they don't have to be integers, they can have decimals, all sorts of stuff like that. But there are certain operations in math that can cause us to not get a real value. 0 divided by 19, that is 0. The square root of -16. Well, square root means that we have to think of a number. What number times itself gives us -16? Well, at first thought, you might think -4. But what is -4 times -4? Well, that's a positive 16, so that doesn't work, does it? And certainly, positive 4 squared is 16. So there's no real number that when you multiply it by itself gives you a negative number. So we're going to say no real value. This is not a real value. You know, as a spoiler, as we'll learn, there is a kind of value that we can describe this with, but it's not what we call a real value. All right, 14 divided by 0. Well, we're not allowed to divide by 0. So that is no solution. No real value, I should say. No real value. And it probably doesn't make a lot of sense to you right now, but in fact, I could go ahead and remove the word real here, because it turns out that there's never a value to this. There is no time that we're going to be able to divide by 0, even with some funky advanced math stuff. That's always going to be an issue. So yeah, no real value. And okay, now we have the cubed root of -8. So we need to think of what number can you multiply times itself 3 times and get -8. Well, again, we're probably thinking -2, so let's try it. Earlier we tried -4 with the square root of 16, it didn't work. Well, negative times a negative times a negative, that's 3 negatives, right? So the answer will be negative. And 2 times 2 times 2 is 8. So it turns out that this is just me checking. The answer is indeed -2. So there is a value to the cube root of a negative, but there's not a real value to the square root of a negative. Okay. Before we leave that, I just want to go over, one last little thing about this divide by 0. I want to make sure that we really nail this down. So let me just kind of go through how I remember that. So if you have some number, okay, like we'll just call it k, all right? So k is some number, but it's not 0. So it could be like a 7, a 5, or whatever, okay? So k divided by 0, and let's talk about 0 divided by k. All right, so can I divide 0 by some number k? Well, what we say is that's okay. That's okay. Get it? 0 over k, that's okay. That's just 0. But what about k over 0? Well, those of you that follow boxing know what that is, right? That is a knockout. No way, no how. So that's just kind of a little easy, cheesy way to remember that that is undefined. Okay? No real value. Undefined. Now, what about the mathematical reasons? Why was this okay, but this not okay? Well, let's take a look. Just bear with me just a little bit further. So the reason why is because we need to think of division as undoing multiplication. So just to put some real numbers in it, let's use 7 and 0. So I want to use black here. All right, so let's say I had the number 7, okay? And I'm going to ask, what is 0 divided by 7? Well, 0 divided by 7, it's got to be some sort of number, right? It's got to be something, and I'm just going to put a question mark in it, okay? Well, since division undoes multiplication, we know that whatever that is, it needs to be something that if I multiply it times 7, gives me back the 0. Well, what number times 7 is equal to 0? Well, anything times 0 is 0. So that's why the answer is 0. Let's try 7 divided by 7. Well, hopefully you realize that's 1, right? Well, why is that? Because if I move this over and call it multiplication, because that's what division is, we should get a true statement. 7 equals 7 times 1. That's true. Just one more to nail this down. 14 divided by 7. Well, what is division? Well, that's 14 divided by 7 is 2, right? Well, why is that? Well, that's because 7 times 2 is 14. So you see how that works? That's how division is defined. That's why we have keep, change, flip. It's defined to be the reciprocal of the multiplication. So what happens, though, if I have 7 divided by 0? Well, what would that number be? Well, if we could figure out what that number is, I mean, we just discussed that it doesn't exist, right? But if we, for some reason, thought we knew what it was, then that means it would be a number that when I multiplied it times 0, I have to get this back, right? So whatever the answer is, when I times it by this, has to give me that, right? So it would have to be some number that if I multiply it by 0, I get 7. Well, that violates what we said up here, right? We said any number times 0 is 0. So how could that be? What number would there be that would make this happen? Well, there isn't one. And if you try and make one, all the math just falls apart and it doesn't work. So you cannot divide by 0. KO, knockout. All right, one more little treat though, y'all. One more little treat. Math is often very interesting though. Here's my next question. What is this? Well, it's undefined, right? We said no real value, and it turns out it's no value at all, so we actually say undefined. But what if we could imagine what that number is? Well, let's just call it again. Let's call it a question mark. Well, what I've been saying is that I have to be able to take this over to the other side and make it multiplication. It has to equal that, right? So can we think of what this number could be, this question mark, so that 0 times this number would give me 0? Is there a number that you could put here for question mark that would make this statement true? Sure. About 3, 4, pi, 9, any number. So it turns out that 0 divided by 0 is undefined, not because there's no number that the answer could be, but it's undefined because it could be any answer. So dividing by 0 not allowed. Dividing a 0 by 0 is not allowed for a really weird reason though, right? So we call that the indeterminate form. Much more on that later in math class. Okay, enough diversion. Let's go back. So you should have a place to kind of summarize in our notes what we've been talking about. Let's make sure we get that filled in. So I've got, when evaluating expressions for real number values, you must remember that you cannot what? You cannot even root. We were able to cube root, right? You cannot even root negatives. So even roots are, they have the square root, the fourth root, etc. And we'll look at some other ways that can be written. There's an implied 2 right here. So the square root is so common we don't write the 2. But there really is a 2 right there. That's why the cube root symbol in the previous problem had a little 3. Okay, so there's square roots, which is the second root, fourth root, sixth root, eighth root. All of those, we can't do it of a negative number. It's not going to be a real value. And we cannot divide by 0, ever. That is not allowed, y'all. Do not do it. Okay? All right, let's take a look at another example problem. This time, finally, we're going to put some letters back in math. You knew it was coming, right? All right, we're going to evaluate the following variable expressions for the given values. 2x minus 3y. Well, this is really just a matter of replacing the x with what x is equal to. X is equal to 5, so I just put a 5 right there. And a negative 2 right there. 2 times 5 is 10. 3 times a negative 2 is a negative 6, so this becomes a minus a negative 6. But minus a negative is plus a positive. So when you have a minus and then you have a multiplication, count that minus in your count of how many negatives you have in the multiplication problem. We had 2 negatives in the multiplication, so the answer has to be positive because it's an even number of negatives. That's why I end up with 10 plus 6. So that becomes 16. All right, negative x squared for x equals negative 3. Remember, the squared only goes to the number immediately in front of it, not the minus sign. So we have a minus. And then I'm going to plug in parentheses a negative 3. And that's just a good habit to always replace variables with values in parentheses for this very reason. It helps you understand that they're multiplication. It helps you understand order of operations. So the negative from the negative 3, I plug that in parentheses because that's the x value. The x value contains that entire negative 3, and that entire x is squared. So that is going to become this part here. I'll do this part here first. This becomes a positive 9. However, there was also this negative on the outside from here, right? That negative brought that down. So the answer is negative 9. And it's kind of interesting if you think about evaluating example B for a positive 3, you also get negative 9. That negative out in front kind of forces our answer to be negative. All right, we got a couple more examples to do here on this set. So we bring those over. There we go. All right, x squared minus y squared for x equals negative 2 and y equals negative 1. So again, we're going to plug in parentheses because we're dealing with squareds and negatives. So we got to be careful. That's kind of the theme of today. All right, negative 2 squared. The negative is in parentheses, so it becomes a 4. Negative 1 squared becomes a 1. But there's still that minus out in front, so the answer becomes a 3. All right, the square root of x squared for x equals negative 9. Okay, so square root negative 9 squared. Okay. Negative 9 squared, because the negative's in parentheses, becomes a positive 81. And the square root of 81 is 9. That's kind of interesting, though, don't you think? That we started with a negative 9 and ended up with a positive 9 through this kind of squaring and square rooting behavior. I wonder if you found that answer surprising. All right, so you've got some practice problems to do, so pause the video, and then we'll check back in and make sure you did them right. All right, welcome back. Let's see how you did. We have 2a, so that's 2 times 5, minus 3 times 2, plus 1. So that becomes 10 minus 6 plus 1. 10 minus 6 is 4. 4 plus 1 is 5. All right, 7m, so 7 times a negative 1 plus 2 over 3. So that becomes a negative 7 plus 2/3. All right, looks like we got to add some fractions, right? This 7 is 7 over 1. We need common denominators to add fractions. So I'm going to multiply this by 3 and 3 so that my 1 on the bottom can match the 3 from the other fraction. That gives me negative 21 on top over 3 on bottom plus 2/3. All right, so I've got two different signs here in an addition problem, so it'll be like subtracting, but I take the sign of the bigger number. So this is a negative 19 over 3. All right, x squared minus 1 over y plus 2. So I have 5 squared minus 1 over 4 plus 2. And I wanted to show you me plugging them in without parentheses, because maybe some of you didn't plug it in parentheses either. And I want you to know that's totally okay some of the times. As long as, when you got that squared there, you need to be careful. If you're plugging in a negative number, you must write parentheses down, because the parentheses must indicate that the negative is squared as well. But since it's just a positive number, I can just write 5 squared. So this becomes 25 minus 1 over 4 plus 2 is 6. 25 minus 1 is 24 over 6, and 24 can be divided evenly by 6 to give you 4. All right, and then you had one more problem to do. Oh, did it again. Let's see. We're going to plug in a negative 3 for x. The negative 3 must go in parentheses. I want to make that very clear. Even if you get the problem right, if I see this on someone's work for this kind of problem, even if they correctly get the answer of 4, this is not okay. Because you don't want intermediate steps that are wrong. If your intermediate steps are wrong, you're going to confuse your audience, and math is more than just getting an answer. It's about convincing other people that you have the right answer. And also, some math problems get really hard and have to be worked by multiple people, and you need to be able to communicate with each other. So, in other words, write it in parentheses. 9, that negative is squared to come out positive 9 minus 5 is 4. Okay, at the end of the notes, there's usually an exit ticket for you to think about. That's for you personally. I want you to take a look at it and see what you can figure out. Today, the exit ticket is that this first lesson is a review for you, hopefully, but sometimes when we review our fundamentals, new understandings or new questions arise. I want you to state one idea that you understand better as a result of today's lesson. Then state one idea that you're still confused about, or more confused about, as a result of the lesson. So take this time and write something down in your notes. Hopefully, when you come back and look at these notes later on, if you need to review your Algebra 2 at some point, you'll have a moment in time where you can remember this moment and what you learned and what you still hadn't learned. Okay, that's the end of our first lesson. Until next time, take care.